All right, so by the request, I made my cursor a little larger. Everybody see my cursor better? I changed the color and make it larger. Is it better? Good. Okay, so let's. Yeah, so the question is that the recording will be distributed online. Yes, I mean, that's the plan. And let me actually communicate with Tom, the project manager at SCAG, and we want to make the video file available to download somewhere on the online. So that's the plan. So we will reach out to you. I mean, since you guys shared your email when you registered the course, we have all those your contact information, and we will make sure to reach out to you and let you know the where you can access the video files. Okay. All right. Then the third sessions of today is data querying and data attribute data processing. So the goal of this session is fully take advantage of attribute data of GIS. Many of you guys may use the Excel when you guys deal with the attribute table, like an Excel spreadsheet, right? I don't know how extensively you guys using Excel, but you may know that Excel has great features and functions that you can process and you can build the attribute data. I mean, I know some of you guys use the Excel just as your extended calculator, right? But you know that Excel has much more than calculating functions, right? So have you okay, how many of you guys have created something called pivot table in Excel? Pivot table, anybody? A couple of them, okay, a few of them, okay, so yeah. I mean, things like that, right? So Excel, if you take advantage of Excel, I mean, you can do way more than just simple calculation, right? So I think almost everything, even some beyond what Excel can offer you, I mean, GIS can offer you as well, right? So here, some examples that, oh, if you want to do some calculation in the land use and housing, so whatever the planning application calculation, let's say per impervious surface calculation or buildable area calculation and things like that. So, I mean, some of you guys may bring, like the discussion that we had yesterday, some of you guys may bring this GIS data to the Excel and do the calculation in Excel, but I mean, you don't have to do it. You can do everything in a GIS, okay? So let's explore what you can do with attribute table at GIS side, okay? In the GIS end. So the first things that you can do is like a descriptive statistics. So, okay, why don't we start GIS? Why don't we add new data? Let me start my GIS. And let me add data for this session. So if you go to the Geo database that I shared, there's like a session 3 and 4. So why don't we add those two layers in the GIS? And let's play with it. For now, we don't need anything. We don't need this block group layer. What we're gonna use for now is that we're gonna use this Pomona parser layer. So let's zoom into the Pomona parser. So this is the property parser data of the city of Pomona, where actually I am. And let's open attribute table and let's take a look at it. So if you take a look at this attribute table, I mean, as I said, this is like a Pomona property parser data. We have a lot of information that's actually, yeah, a lot of attributor data in that attribute table. It goes from like the owners and addresses and so on and so forth. There's a lot of data, right? So if you take a look at it, there's a lot of data there, and we're gonna explore a little bit of data function using this data, okay? And actually, the first things, the most important things of the attribute table in ArcGIS is that the number of records, right? If you take a look at the bottom left corner, it says for now 0 of 33,421 selected. So what does that mean is that there's a 33,421 records in this table. So total number of row is 33,421. Then many property in the city of LA, in the city of Pomona, I'm sorry, right? So you can quickly get to know how many records in the table by opening it up, that attribute table, right? And then first, sort of like tools that I want to explore with you guys is this descriptive statistics tools. I mean, in Excel, you know, like if you want to get the, you know, average value of one column, for example, you can select them all and equal average, whatever that functions that if you plug in the Excel, you can get the average value, right? So you can get the mean, minimum, median, average, or whatever that descriptive statistics value, if you want to pull out from the data set in the Excel, you can type in the functions and you can pull out the information. I mean, same things that you can do in GIS. It's much simpler. So, for example, I want to take advantage of this. Why don't we use this field, the AV total field, for example? I mean, any field with numerical data is totally, you know, employed for this exercise. But the field that I want to use is this AV underscore total field, which is the appraisal value. So total, you know, we can you know, take it as the value of the property. Okay, so that's a total value right here in this column. So I want to know, for example, what's the average value? What's the average property value in the city of Pomona, right? Those value stored in the cell is like representing the value of each individual property. But if I want to know the average value of the property in the city of Pomona, then what I want to do is that I want to right click on that field, and then I can click here, statistics. Right click. Yeah, the video file is not available yet, but we will make the video files available, and we will reach out to you and send the link of the video files that you can download it or take a look at it, okay? So why don't you guys keep in touch with me and Tom, and we will make sure to reach out to and send the link of the video file to you guys, okay? So everybody here? So everybody here? So when you guys open, when you guys go with that statistics tools, GIS will calculate all the descriptive statistics value for that particular column here. So mean, median, standard deviation, number of records, right? So as you can see, the number of records is slightly different between this count and this number at the bottom. That means a few records, right? The few records does not have information, average, I'm sorry, not the average, but property value data is not available in few column. That's why there's about 100 record difference here. So null is 99 precisely. Nulls mean no data. No data is there. So 99 record has no data, and minimum value is 0, maximum value is this, summation of total value is this, so on and so forth, right? So with one button clicks, then GIS will calculate descriptive statistics very quickly, and you can take advantage of it, right? So, to me, it's simpler than Excel if you want to get the Excel, and otherwise you're using that data analysis tool, you have to individually calculate mean, median, average, whatever that, with the Excel functions. But here, with a one button click, you can pull out all those data in a one shot. And additionally, as the GIS gives you guys skewness and kurtosis value. I don't know how familiar you guys with those values, but it's not a statistics class. But if I briefly address what skewness and kurtosis mean, is that skewness is about how your data is skewed, right? And GIS, along with this descriptive statistics, GIS provides you a histogram, right? So if you guys take a look at this histogram value, you see how your data is skewed, right? And everybody is sort of familiar with the term called normal distribution? Yes? No? So the skewness is about how off your data from normal distribution. So normal distribution, if I express normal distribution with a histogram, everybody understand, you may see this, bell curve shape. That's it's not a perfect bell curve shape, but bell curve shape representing normal distribution, right? So skewness, this positive skewness value means your data is actually skewed to the right. Like the way this histogram in the GIS represents, right? That skewness. And negative value of skewness mean your data is skewed to the left. That's the what this skewness value indicates. Okay, and kurtosis mean how thin or how thick your data is. So the small kurtosis number means your data is very thin, like that. Or this large kurtosis mean your data is really widespread, very thick data. That's what kurtosis mean. So the point here is that with the one actually button clicking, GIS can retrieve the descriptive statistics very quickly, and you can take a look at it in a one shot. Okay. And when you, if you want to take a look at descriptive statistics of other field, you can switch field and select any field that you want to take a look at it. Take a look at the descriptive statistics here, and then you can quickly switch it to any other data field, and you can get the descriptive statistics. Also, if you close descriptive statistics windows, that doesn't mean that you lost the descriptive statistics value. Actually, that's stored right here. So if you open this item again, then you can go back to your histogram and descriptive statistics value. So that's preserved right there until you close your GIS software, okay? Another actually very unique features. I mean, this is something that Excel cannot do, and very unique feature is this something called calculate geometry. So what does that mean by calculate geometry is it's something like this. Let's say if I ask you guys the area of this particular property, right? So if I ask you, could you calculate area of this property? Then, I mean, you can refresh your memories that you learned, the equation that you learned from your 5th grade math class, right? So the width multiplication of the depth, then you can get the area of these square shapes of properties, right? Everybody remember that equation, the formula, right? Yes or no? Hey, right? All you graduate from you got this, right? So the 5th grade geometry class, you learned how to calculate the area of this square. That's what I'm talking about, right? The calculate geometry, what I mean by that is that, why don't I calculate area, for example, of this polygon? I mean, obviously, calculating area of this rectangular shape is really straightforward, but what if I ask you, hey, what's the area of this polygon? It's gonna take a while, right? It's gonna little challenging. I mean, I don't doubt that you can do it, but it's gonna take a time, right? But I mean, luckily it's a GIS. We don't have to do any manual calculation. We can quickly calculate the area of that polygons. So for the placeholder of that polygons, that area value, why don't we add a new field? Why don't we give it a name of the field? Let's say, let me call area underscore P, whatever name, okay? And then data type, I want to use float because I want to preserve the decimal places value. So basically my plan is that I want to populate this field with the area of each polygon in the units of acres. So simply I want to know, how many acres of each property is.
Excuse me, though, can you explain the difference between double and float?
Between double and float, it's basically same thing, but only the difference is that range of data that you can store. So float, obviously you can preserve decimal places, but float is only like 4 bits of data. So the number of range that you can store is from a negative whatever this number, right? to positive this number. But double can store even larger range of numbers from this to this. So it's 8-bit number. So in general, what are we talking about? This is like a 38-digit number, right? 37-digit number. So mostly, if you guys use the float data type, reasonable, except few, exceptional cases, you can store the numerical value without any problem. I very rarely use the double because, as you can see, double data type can store even larger range of the data. I mean, that's only the difference. Float is 4 bits of data, double is 8 bits of data. But both of them can store decimal places. Okay. So my case, I mean, acres value that I want to store is not, gonna have more than, hundreds, not hundred, like a 30 something digit. So float is good, So I want to populate this field called area P with the acres value of each property. Then I want to right click on the area underscore P, and I want to go to the calculate geometry. Yeah, my computer is a little slow, so please be patient. No. Okay, so this area underscore P, that's the field name that I'm about to populate. And what kind of geometry that I want to calculate here? I mean, as you can see, we have a lot of options, right? Area and parameter and number of part, number of vertices, XY coordinate of centroid, so on and so forth. A lot of options. So I want to go with the area option. And as you can see here, there's a 2 area option. One just simply saying area. The other one says geodesic. What's the difference between geodesic and area is that if you go with the geodesic option, GIS will assume your geometry is a 3-dimensional shape. So for example, if you want to calculate the shape of a state, like a state of California, I mean, if we take a look at the GIS on 2D map, it's a flat 2D shape, but along this sphere shapes of Earth, the shapes of the California does not necessarily 2D flat shape. It's a 3-dimensional shape. So geodesic option will calculate area assuming this geometry has a 3-dimensional shape. The area without geodesic is very assuming this is just 2D flat surfaces. You can choose, whatever that's applicable for you. But to me, in this case, we're calculating, the area of property, which is very kind of a relatively small dimension. So I don't think there's a huge difference between geodesic and just regular area. So I just want to go with the area, but I want you guys have a good understanding of the difference so that you can choose whatever, the applicable option for your case, okay? And then what you want to select here is the area units. So as I said, hey, I want to calculate that area in the unit of acres. So I want to select US survey acres. So long story short, if I summarize what I did here in this window is that I want to populate area underscore P field with the area of each polygon in the units of acres. Okay. Coordinate system, you don't have to worry about it. You can just leave it as a blank. Then GIS will grab the default coordinate system, so you don't have to worry about it. And if you all you want to do is just simply click OK. Then this field will be quickly calculated, and the field will be populated with acreage value of each property. See, that's the actually my computer takes times, but that's the power of GIS. GIS has real world coordinates of every single polygon in there. So taking advantage of that information, GIS quickly calculates the area in this case and then populate that field. I mean quickly, but my computer is not quickly, but you see what I'm talking about. It's gone. It calculates. So actually my computer is typically faster than this, but I'm using my memory a lot for the Zoom meetings and everything. That's why my computer is a little slower. I want you guys understand and be patient to do it. Okay. Okay, so the question is the US survey mar and okay. So to be honest with you, I do not know what exactly that statute marks. I always use the US survey Mars or US survey acres. I mean, that's the units that we use in this country use, right? I never even pay attention to any other options. I always use the US survey acres and Mars and things like that. So I mean, to be honest with you, I don't know exactly what's the difference between the question is asking what? Yeah, this Mar and what is the other Mar? Yeah, this Mar, right? So I mean, my best guess is that this is, I think they're almost the same, but this is the Mars that some European country use, and this is the units that that America use. So that's my best guess, but I always use the US survey units. Yeah. But the point here is that it populates the acres value very quickly, right? So we can acquire sort of like a geometry areas based on the shapes of the geometry on the GIS, right? Next exercise that we're gonna do is so-called data summary. So when I ask you a question about how many of you guys have created pivot table, some of you guys show me your hands and express your experience with the pivot table. And what we're about to do is exactly same thing as the pivot table in Excel. So what does that mean is this: earlier we were calculating average property value in the city of Pomona, but what if I'm interested in average property value? Hold on, let me show you. By land use, right? So here we have a land use code, land LU19, that's the SCAG land use code, and we have this property value field. So let me bring them right next to side by side so you can see better, right? So now what I'm interested in is that I'm not interested in overall average value of the property, of average property value in city of Pomona. I'm interested in average property value by different land use code. So in other words, I'm interested in what's the average property value of single family residential property, what's the average value of the commercial property, what's the average value of office property, for example, something like that, right? So this is the land use code, land use classification. This is the average, not average, I'm sorry, appraiser value of the property, right? Then, if you are familiar with that pivot table concept in Excel, pivot table actually works something like this, right? So for example, this is the zoning code, this is the value field, like exactly example right here, oops, example right there, right here, right? Only the difference is that it's a land use, not zoning, but see, if I want to calculate average value by zoning code, then I have to handpick all those records or row that share same land use code and aggregate them together using average value, right? So if I repeat this one by one for each different land zoning code in this case, then I can get this summarized table, which means showing this average value by zoning classification, right? So that's the conceptual things, right? That's the sort of like so that's the conceptual, the concepts of this pivot table or summary tables. So that's the something we are about to do. So right now, what I want to do is that I want to right click on my LU19 field. And some confusion from usually from my students is that, oh, do I have to right click on the this AV total field, or do I have to right click on LU19 field? Either way is okay. I mean, you can switch it later in that summary table windows, but if you want to save one step, I recommend for you guys to right click on the land use code, land use 19 field, okay? So right click there and select this summarize button. Then first box pointing out this table, Pomona parcel. Second box asks you to save the output. In this case, the product of this process is a DBF, database table, standalone table file. So you may want to give the name, right, of that output file. So for example, oh, I didn't link. So if I want to save this file in the same geodatabase that we're using right now, let me navigate to the folders and geodatabase. No, not day one, day two. So let me save underneath here. So why don't I give it a name? Value by land use code, land use, why don't I call value by land use? Okay, so just that's the very simple things for the name of the output file. Okay, and then field, in this case, I want to select AV total. That's the field that I want to do the calculation, right? I want to apply my calculation. What kind of calculation? Average calculation. So you can select one of statistical calculation options here. So average calculation, mean. And if you guys take a look at here, there's something called case field. It's already populated with the field name LU19 because we right-click on this LU19 field. That's why it is populated here. If you want to change it to something else, you can obviously change it to the something else, but I don't recommend it. Why? If I explain what's going on in this window is that I want to calculate AV total value, the average of AV total value by land use 19. In other words, I want to aggregate all those records that share same land use code, and then I want to calculate the mean of that record, the mean of the property value total of that record. That's what it says. Okay, that's what you do. So you want to select the field to apply your calculation here, and you want to select the field that has the so-called case field. In other words, that a record share the common value. In this case, land use code. So if I click OK, what's going? Okay. Something went wrong. I don't know. There's nothing is wrong with what I did. So let me give it a try again. If that doesn't work, I have to restart my GIS. Sometimes GIS do the funny things. So let me try to save this somewhere else. Everybody got your value at the table, or some of you guys had like an error message like me? I don't think you guys had an error message like me. I don't know why, but there's something with my computer.
I think there are several people that got the same error message like you.
Really? Okay. This is a very simple thing. I don't know why.
Do they need to be in a geodatabase?
No. See, now this time I get a warning message, but I still get the output. I expected this warning message. The reason why we got the warning message is that in some record, there is no data in this land use code field. So there is the null value warning is that, oh, you may understand there is some no data in this record. I mean, that's why I get this warning message, but this is a warning message, not an error message. But I mean, to be honest with you, I don't know why I had an error message, before, because I did exactly the same thing. And now I got my output. Because of this record, we got a sort of like a warning message, because as you can see, there's a blank in the land use 19. field, right? So that's the why we got a warning message, but I mean, let's ignore this. And let me explain what this output means. So for example, land use code 1100. There are 54 property in the city of Pomona that designated as a land use code 1100. And average property value of those 54 properties is a little less than 550,000. So and so forth. So if you scroll it down, GIS does the calculation by multiple land use, like 56 different, 58, but excluding those two records at the top, there are 56 different land use codes, and GIS did all those data summary and calculated for you average property value for 56 different land use codes. Quickly. Okay? Everybody understand? Okay, so one thing is that, yeah, one thing that I want to tell you is that if you want to save it, when you export it, for example, no, not export it, let me explain. I got your point there. So, yeah, the reason why I got an error previously was that I was, if I remember correctly, first time I tried to save underneath of feature class, feature data set, right? But still you can save the tables and the feature data set. I don't know why I got an error message. I mean, let's take a look at. So, oh, this is maybe good exercise. So whenever you guys get an error message, there is a way that you can check why you got the error message, right? So this is my error message, right? If I click this error message, so when you do the GIS project by yourself, you may want to, do this like problem solving approaches, right? Whenever you get an error message, you may want to click on this error message. Then you can go to the sort of like ArcGIS Help Center. It will explain it here. Incorrect path. I don't understand why it's incorrect path. I mean, in this particular case, these error numbers and the description and solution here is actually does not help me a lot. I mean, that's why earlier I didn't pay attention to it. But in some cases, when you get an error, this error code and error message, will have some reasonable risk solution. So whenever you guys get an error message like this and click this error message and open the ArcGIS Help Center and take a look at the solutions, that will help you guys some cases. I mean, in this case, I mean, to be honest with you, I don't understand this description of error. I mean, my data is not locked by another users or application. I mean, this is a thing. This is not exactly the correct error sign, but anyway, so that's the one way that you can kind of double check what's going on with what you're doing, right? So, yeah, like the way that it was Riley yesterday. I mean, GIS actually record every single things that you do in this history button, and you can find, see, this is what we've done so far, and you can get a log file and checking the error message in the log file, okay? And one more thing that I want to point out is that when you save, so as you can see here, my case, I save this file in the regular folder, not the geodatabase. And whenever I saved this standalone table in the regular folder, it is a good idea to specify the file extension, which is the .dbf. Okay, but when you save this standalone output table within the geodatabase, you don't want to type dbf. So .dbf is only for the case that you want to save this output in the regular folder. I want you to remember that difference, okay? So that's data summary. So you can, you can quickly save, and not that save, but you can quickly calculate the summarized value of the group of records categorized by the consistent value, or right, so that you can get the aggregated value of the multiple records quickly. So if you know the pivot table in Excel, it's a lot similar to the pivot table. Okay. Field calculator. It's a $1 million question. So it's a very popular, it's very powerful tools here, and like a name suggests, it's a calculator. So you can calculate any values, like the way that you use the Excel to do any mathematical calculation, right? So the interface, to be honest with you, it's a little complex, but the way that you can use this calculator tool is that, exactly the same way that you use the Excel to perform mathematical calculation. So for example, I want to calculate property value per acre, right? The property value that we play with so far, yeah, it's a good indicator, but it's not an apples and apple, comparison. If we talking about the property value comparison between the properties. Larger property may have a larger value, so we want to take a look at unit value, right? So remember, when you guys go to the grocery shopping, when you purchase something, like a pack of meat, larger pack become expensive than smaller packages, obviously, naturally, automatically. So, but if you want to compare real price, you may want to compare like a price per ounce, right? Unit prices. That you may want to pay attention. So here, in this case, the unit price for us is that, see, the value per acres, right? So that's the unit price that we may want to use for apples and apple comparison. So obviously we have this property value data right there. And if we divide this property value by the area value that we created here, right? This acreage value. If we divide this value, the property value, by acres value, then that's the dollar per acres, right? That's a unit price. That calculation, simple mathematical calculation, you can do it. So why don't we create another field? This is a little drawback of GIS. In Excel, you can just quickly take advantage of the existing rows and column in the spreadsheet. But in GIS, drawback is that you have to create a field in every single time that you need to build a database or you need to conduct any calculation. So if I name this field, let's say value per acres, and float one more time is the data type that I want to choose. And if I create a field, close. Right, so if I scroll all the way to the right and there's a new field populated, now I want to do this simple mathematical calculation, the division calculation, right? So here, right click on the value per acre field, and there's the button called menu called calculate field. I want to open this calculator. It's called field calculator. So let's open this. Then where you want to pay attention to is this box. So if you take a look at carefully, it says value per acre equals, right? Then mathematical expressions right there. So all you want to do is that populate your equation in this box, right? So in this box, it's very simple. So here, if I scroll down and find my name of a field that I want to use, right? AB total. See, multiplication, division, plus, minus sign, right there. You can pick up from there, or you can type, right? Divide and area P, right? So value divided by acres. Does that make sense? Okay. So all I want to do is click OK button, for example. The difference, difference between apply and OK button is that if you want to continue to do any calculation, you may want to click apply button. Then this window will not close. But if you wanna, you feels like you done with the calculation, if you don't want to use this windows one more time, then you're gonna click OK. Then this window will be closed. That's the only difference between those two buttons. So you can click either one of them. So I click this apply button. Then GIS will do the calculation for you. Populate all those cells with that division calculation. Okay, so once again, it says some warning message. Let's not worry about it. Once again, it says null. Yes, I mean, if you want to undo, there's a pros and cons, right? So if you go with this without the undo button, then you're not going to be able to undo it. But if you enable the undo, I mean, you can, you can undo it. But my personal actually practice is that I don't really pay attention to this one. The reason why is that, in the case that my calculation went wrong, then I can always overwrite this value. So, I mean, if you are careful with your database building, then, I mean, this is not terribly, how can I say, significant. In the case that you mess around the original value or original columns that exist, then you may want to pay attention to here. But I mean, this is a new field that I created. If this went wrong, this calculation went wrong, then I can always override. So I didn't pay attention here. But yeah, you can undo it. You can, you can take advantage of this undo buttons. Okay. But the point here is that now you can see how similar this calculator is to the Excel calculation, right? So the way that you guys are using Excel to calculate mathematical equations, mathematical formula, you can do it, in GIS, like using this calculate field tools. I mean, even further, if you want to apply some sophisticated mathematical calculation like log and sine, cosine, whatever, like exponentials, all those advanced sort of like a mathematical formula and functions available here, and you can grab it from in this box. Okay, so that's also doable. Okay. The next topic, this one. Next topic is calculating text value or processing text value. Means calculating text value sounds really odd, but you can do it. And before we jumping into the this exercise, I want to go over very basic fundamentals of this text data processing. So text data is always case sensitive, okay? In GIS, for example, uppercase SCAG value is different from lower case SCAGs. GIS recognize uppercase SCAG versus lowercase SCAG. GIS recognize them differently. So you have to always keep in your mind your text value should be case sensitive. Okay. More importantly, every single text data value has place number, starts from 0. So the first character in the text value is place number 0. Don't ask me why it's not 1. That's how computer scientists code everything. So this is not only in the GIS, in the computer coding and computer programming world, everything starts from 0. Okay, so every character of the text value has a place number, sequential place number. Another important point is that one space takes one place. So if you have 2 spaces, then there's maybe 4 and 5. Place number 4 and 5 may assign to these 2 spaces here. In this case, there is 1 space only. So, this 1 place number for there. So 1 place number is assigned to the 1 space. I want you guys remember that. With this basic concepts or basic understanding of text value, then what you can do is that you can use this very simple Python code, and you can kind of like chop it out the text value that you want from this long text value. So for example, if you want to chop out or filters out the word scale from this text value, you may want to type the name of the field and open bracket 0 colon 4 close bracket. Then the 0 mean actually the place number of a starting point, and this second number mean number of character that you want to extract out. So see, from 0 and 4 characters that you want to extract it out, then this Python code will return the word SCAG. If you want to pull out or filters out CPP, for example, then you may want to type 5. That's the location or place number of the character C, and 3 characters, then 3 plus 5, 8. Then GIS will pull out CPP. Okay? I mean, there are so many actually Python commands that we can use for these purposes, but I want you guys just kind of remember 2 Python command. One is this bracket, and the other one is something called find. Find command will requires this the text character, actually the character that you search, and then starting place and then ending place. If you leave ending place without anything, that's fine. So then GIS will find it out and find it out and return the place number of the character that you search. So for example, if I said course find double quotation space double quotation 4, what does that mean? Is that I want to start from this first space, which is the place number 4, and I want to find it out whatever whatever place number of the next space. Then GIS will return 8, which is the place number of a second space. Everybody understand? I know it's a little complicated, but the bottom line is that we want to extract it out, the whatever part of like a text that I want to filters out. For example, the exercise is that I want to do what I feel like I'm a little far behind, but let's move really quickly. So if we take a look at it, the owner 1 field, this is the name of the owner of the property, okay? And if you guys take a look at it, there is a little variation of data stored in this field. When you want to screen out whatever the value that you want to grab it, it is important for you to understand the patterns of the value stored in that field. So for example, if I ask you guys that, hey, I want to create a new field called last name, and I want to only filters out last name of the owners and populate their last name field. So for example, let me add a new field. Let me call last name. And this must be text because I want to populate this field with the text value name. And then let me just use it length of the 50 character maximum. And just an example. And let me okay, why don't I bring the owner 1 field right next to the last name field so that we can see side by side. And All right, so we have 101 field here, last name here, and then I want to populate this last name field with the last name of the property owners. Then, as I said, the most important thing is that you want to identify the pattern. How are we going to be able to find it out the last name? What's the parents? Then what's the, how can we identify the last name here? And let's not worry about those owners, you know, the property owned by some companies, right? The LLC here. Let's not worry about them. I'm not interested. I'm not interested in, for example, you know, this guy, you know, Ubaldi and Aguirre and Lowe, those owners' name. I want to populate those last names here. Right, so, right, if there is a comma, yeah, whatever the text before first comma, right, that's the last name, isn't it? So if I use this pattern and this logic, I want to use the calculate field. And what I want to do, I know it's going to be a little fast, but let's give it a shot to understand, okay? So what I want to do is this. I want to grab the owner one field, the data actually stored in the owner one field, and I want to open bracket, and I want to start from the 0, which is I want to grab the first, right? I want to filters out from the first character, right? I want to filters out first character up to where? Up to where is owner one dot find double quotation, comma, double quotation, actually, comma, even, I mean, I don't have to do anything but 0 and this, and close bracket. Everybody understand what I did here? And if I show you guys in the larger font so you can read better. This is the one I actually type in that box. Everybody understand the logic of that command? This part, actually, this part, not the double, okay. So this part will allow me to have the place number of the first comma. So total, the entire command says that I want to grab the text from the first place. Okay, let me get there. So let me answer to your question after I explain this, okay? So I want to start from the first character and grab all those characters up to the place number of the first comma. Okay, that's what it is. Because location of place number or location of the first comma is all vary depending on number of character of the first name. So we cannot use the fixed number like 0 here. So it's a kind of more dynamic number right here. So this will help us to extract it out last name. And the question here, what is the exclamation mark? Exclamation mark is that how Python read field name. So it's a kind of automatic things. So you don't have to worry about whenever you pull out field name here, exclamation mark comes with it. That's the unique symbol of actually Python when Python reads field name. Okay, so if I use this, okay, difference between Python and Python 3. Python has a different version. So I don't know what Python without the number. Actually, the 3 after Python is the Python version 3. Okay, so in old ArcMap or desktop GIS that use the Python version 2, and it's moving, migrating to the ArcGIS Pro. ArcGIS Pro use the Python coding language version 3. Okay, so later version it is. Okay, so if I click apply, you will see it soon. Then I definitely can pull out the last name with this command. Last name in plain English, but in GIS kind of or GIS approach here or Python coding approach here is that whatever text value before comma, right? That's what it is. Once again, I got some null value. That's why I get this warning message, but let's not worry about it. So see, as you can see, now I nicely populate all those name, first, last name before comma, right? So I know maybe this part is maybe not so intuitive. It is slightly difficult in comparison to any other topic that I so far dealt with. But what I want you guys to remember is that, yeah, you can process text value with the GIS, with the Python command. So here, if you go through here, there's a lot of Python command here that's all applicable to the text value processing. So what I want to ask you guys is that I want you guys, be aware of that you can process the text value in the GIS. And the same thing in an Excel, right? You can do the same thing in an Excel. So you can, either way, either software, whichever software that's going to be you familiar with, you can use it. But the bottom line is that you can process text value and you can filters out only piece of information that you really want if you looking for this kind of a task. Okay, so that's very common task, I believe. And one example is that you can do the same thing in Excel. Basically, hold on. When you find it out, an example. So in Excel, this is actually the survey that I conducted it with SCAGs this time with it, along with this scope of this project. So we ask, or maybe some of you guys respond to this survey question, and we ask, what kind of software do you use in your organization? And then you are actually you are asked to choose the multiple GIS software that you use. So when we downloaded your response was like all aggregated together. Some respondent just choose the one software, but some respondents choose the multiple, GIS software they used in their organization and institute. And those individual GIS software is, separated by this semicolon. If I want to make some reasonable data out of this survey question or survey data, I want to create this table. So, this particular GIS, answered this many times and this many times, this many times. So I want to calculate total count of individual GIS software, and I want to calculate the ratio of that answer, right? In order to build this table in Excel, I need to separate out each individual software from this aggregated response, right? So I did it. I separated out here using some Excel function called meet and write and those kind of like Excel functions, so that I was able to separate it out so that I can count how many individual GIS software was answered, so that I can create this meaningful table. Similarly, I can do exactly the same thing in GIS. So the bottom line is that if you have little knowledge on the Python commands in the GIS, you can separate you can separate out the text value to piece by piece. Okay, so the point is that the most important point here is that you have to find out the patterns. Like John pointed out in the chat box. Oh yeah, comma is the separator between the last name and everything else. Then why don't we grab something to, some value before the comma? Then that becomes a last name, right? So on and so forth. So finding out the pattern and how to take advantage of the, that place number in association with the parents, then you can filters out a portion of the text value from the large text value stored in the field. Okay, so that's an example. I mean, once again, I don't really expect that you become very fluent with this, all of a sudden, but I want you guys to be aware of that. That's the way that you can do it. Okay, then you can invest some time and explore a little more option. Then you will be much more fluent with this process. Okay. Next topic is actually selecting subset. In plain English, selecting subset. In database jargon, it's called query. Okay, query means whatever that we want to, make a subset out of a large data set. So those of you guys, familiar with, let's say, Excel, are you guys familiar with this filter? Right? You can filters and you can select whatever, applicable And you must be familiar with the filter function in Excel, right? Very similar to the filter. You can select whatever subset of a large data set based on the condition that you set. Actually, GIS subsetting function is much more sophisticated and powerful than Excel's functions. Okay, so let's explore these subsetting tools and so-called data query tools. Okay, and first, data query exercise that I want to do is, get rid of this. Get rid of this. For example, I want to use this LA Census block group layer and Pomona parcel layer. So bottom line is that I want to select, as you can see, I mean, this census block group data, I downloaded, straight from the US Census webpage, okay? And US Census webpage only allows for me to download the census boundary by county, So LA County is the finest geographical unit that I can download this data. But let's pretend my study area is Pomona. I'm not interested in any other area outside of the city of Pomona, and I want to select those census block group within the city of LA boundary. I'm not interested in the block group here. Here, I'm only interested in block group within the city of boundary. Okay, city boundary of Pomona. Then I can make a subset of this census block group layer using so-called spatial relationship. Spatial relationship means spatial relationship between this Pomona parcel and LA census block group layer. So relationship between two layers. That's what I want to take advantage of. Okay, so simply what I can do is that I can use this function called select by location. Under the map tab, there's a menu called select by location. Right? And if I click select by location, then what I want to say is that, hey, I want to select LA census block group entity. Let's not worry about relationship here. Let's go with the default intersect. I'll come back here later. And I want to select the LA census block group entity by Pomona parcel. Okay. So what does that mean is that I want to select LA census block group entity that intersect, in other words, touches with the Pomona parcel. Okay, then if I click apply, as you can see, now I selected bunch of block group entity. I mean, select mean you see those some entity is highlighted in blue color. That's what I mean by selection. In the attribute table, for example, if I take a look at LA census block group attribute table, here, 99 record out of 65, 91 selected. So 99 block group is selected and highlighted here. That's what the attribute table says there. Okay, if you want to take a look at only those 99 records, you may want to click this little tiny button bottom left corner, and then you can see only 99 records highlighted, right? So you can toggle between entire data set and the data set selected, right? The subset of it, right? So you can toggle between entire data set and the subset of that data set, right? Here, going back to select by location interface, I'm not so happy with this because, I mean, this is not exactly in the city boundary, but it's selected it. And, there are some other examples that you see, border of the cities is selected. I mean, they are selected, it's kind of barely touches with one of the property. That's why they are selected. So in order to solve that problem, you may want to play with this selection option. I mean, GIS did a really good job in explaining this spatial relationship in the very plain English. So, for example, I want to select completely contain the LA census block group completely contains the Pomona parcel. Then if I click now, you'll see only 85 selected it. So it's much better. I mean, I don't like this one still. The reason why this one selected it is that if you take a look at here, see that property kind of goes over some kind of, contains this property. That's why it's selected it. So except those very rare exception, I mean, this selection relationship did a relatively good job. So I want to manually drop this one. I want to manually drop that one particular polygon. How to manually drop? I mean, you may want to hold the control key and click on that entity there. Okay, then you can select it. I mean, once again, this manual selection it's kind of a little optional, but the point here is that you can make a selection of the subset based on spatial relationship, and spatial relationship option. There's a lot of different options there, so you may want to fully take advantage of it depending on what you exactly want to find it out. What you exactly make a subset out of it, you can choose the one of the spatial relationship option from this long list. Okay, so that's the example of how you can make a subset using the based on the spatial relationship between multiple layers. Okay. All right, so it's like a 3:02. Let's take a 15-minute break. And when you guys come back, let me continue. I am fall behind a little bit on the schedule, but I believe I can catch up in the one last session today. So let's take a 15-minute break. Okay. So before the break, Matthew asked this question: can we make a new layer out of this selection subset, right? Selected subset. Yes, of course. I mean, that's the really good approaches, right? Whenever you guys download the data from multiple resources and multiple sources, and when you want to sort of like clip it out, right? Filters out your study area from this large geographical boundary. I mean, this is really perfect approaches. After you make a subset like this, what you want to do is that right click on the layer, like a census block group layer. And if you go to the menu called data and export features. Okay, so if you click export features, then you can create a new layer, independent layer that only incorporates that Pomona area. So for example, if I save this output somewhere here, let's say, let me call it Pomona plot group, for example. That's all you want to do, and hit the OK button. Voila, you have Pomona plot group, which is just separate, right? So as you can see, I am able to export out, right? Separate out those selected records only, so that's your study area now, right? So what this simple process, you can filters out your study area, from the larger geographical boundary, right? So that's doable. Okay, so that's really advantage of this select by location tools. Okay. The next exercise that I want to do is like a so-called attribute query. So we're gonna make a subset simply based on attribute table. In other words, you guys are gonna setting up the bunch of conditions and bunch of thresholds so that you want to filters out whatever record that fulfill that conditions or thresholds. That's the exercise that we're gonna do. So for example, if I open the Pomona parcel, attribute table, see, right, let's say going back to that property value, AV total, right? I'm just really wondering about property value that's larger than $1 million, for example. I want to select and I want to filters out property value is greater than $1 million. Okay, then what I can do is that I can use this actually tool called select by attribute. Here, it's very, very straightforward, okay? All you want to do is just simply select field that you want to apply and then set up the statements for your condition. So for example, AV total is greater than $1 million. You type in just million and click apply. Then GIS quickly find it out. There's a 934 property is if their value is greater than million. Everybody clear? It's so straightforward, right? Great things about GIS is that you can quickly build up your threshold and condition by combining multiple fields. So for example, I like to find the properties whose value is greater than million at same time, plus this add clause, same time that land use code LU19 is equals to, I don't know, let's say 1241, just for an example, apply. Only the one property that has a land use code 1241 and value is greater than million, there's only one record right there. You see that? So the bottom line is that you can quickly add, multiple condition, multiple threshold, and make your search much more sort of like a sophisticated way. Okay. Those of you guys who familiar with ArcMap or GIS desktop, you will find the interface has been a lot changed, and actually it's a lot user-friendly now. It's really nicely, written in the plain English, like equal to, not equal to, greater than, not greater than, whatever, and also for the text value as well, it has, it's not a text value, I'm sorry, but I mean, my point is that it's well elaborated here. But if you are still kind of, familiar with the old approaches, so-called SQL syntax approaches, and I mean, you can do that if you activate SQL, and you can write down your SQL syntax here. If you remember that SQL syntax, right? So you can quickly do it, but otherwise you can use this interface that GIS provide, and it's really user-friendly. I mean, I'm not a big fan of this, because when my search criteria became really sophisticated, I have to kind of like write down, I have to do a lot, and I have to keep adding a lot of condition there. In that case, I use the SQL, but I mean, let's not worry about the SQL. I mean, you can use this user-friendly interface, right? I mean, it has a lot of features. For example, from the these owners, right? If I want to find it out, let's say property owners that has the same last name as mine. I mean, some of you may know that my last name Kim is very popular Korean last name. So if I give it a try to find my last name of the owners, then I maybe find some record. So, for example, right? If I says owner one, the value starts in the owner one field, which is a text value. In this time is slightly different from the numeric quantitative value. I can say begins with Kim, right? Case sensitive. So I type in all upper cases, and if I use the comma, that will be impose my last name. So if I click apply, there are 53 records, right? 53 property owned by all last name Kim. Actually, that doesn't mean that I own the properties, but the owners share the same last name as mine. Clear, everybody? So my point here is that there's a lot of a lot of options you can set it up. Okay, so for example, if you're looking for the let's say land use codes, and if you're looking for the property in a couple of land use classification, not one but a few, then you can go with this option called include the values. Then interface is exactly same as the Excel interface, right? So you can just check whatever the land use code that you're interested in, click check and apply, then you can find that property fulfill that condition that you look for, right? And when your search criteria become really, really sophisticated, it's become very complicated, for example. You don't have to put everything in a one shot at this search criteria, okay? What you can do is, get one by one. So let's say, for example, like an example that I showed you earlier. Oh yeah, I'm interested in the property value is greater than $1 million, but also in the same, in a couple of land use codes, a few, then obviously you can keep adding the clause here, and whatever search condition that you're interested in, you can put it in here. But actually, you don't have to do it in a one shot. So, for example, you can go step by step approaching. For example, first of all, I'm interested in property whose value is greater than million, right? And apply, and let's find all those property. Yeah, all those property value is greater than million, so 934. I found it there. And then let's say if you're interested in a couple of land use codes, then what we can do here is that we can take advantage of this option. There's a option that you can choose. You can go from here, and then you can add to the current selection. You can remove from current selection. You can select subset from the current selection, switch the selection, whatever. And there's options, right? So if you're looking for the, let's say land use code 1234, also the value is greater than million, then you can obviously do, okay, select subset from the current selection. Then now I can tackle the land use codes, right? So a land use code equals whatever land use code that you're interested in. Let's say 1243. Let's give it a try this one. None of the record meet this condition, but I hope you understand my point, right? So when your search condition gets very complicated and very complex, then you don't have to tackle all those multiple conditions at once. You can just go step by step approaches, select a subset and then add another subset on the top of the subset, or make a general subset and take a subset out of the general subset, one by one, step by step. If you go that approaches, then you can finally get exactly the record that you want, right? So you can go this step by step approaches. Everybody clear? We're good? So that's the quick overview of data query, which is very powerful, which is very, very well, utilized in the GIS project. And here, there's like a couple of application of this data query. One of them is something called definition query. So, let's say this. Oh, okay, this is my general study area, and like examples that we did it, I'm only interested in the property whose value is greater than million. I'm not interested in any other property. Let's say I'm I want to purchase this property, and I want to choose the property that I want to purchase. I'm only interested in properties, over $1 million, right? So I don't want to distracted by all those property in front of my eye. I just want to super focus on that property. Their value is greater than $1 million. Same time, I don't want to delete the rest of them, because who knows what, next time I may want to use this data for some other purposes. So like examples that we did it before, I mean, we can make a subset, then, and then we can export it out, create a new layers. We can do that, but creating a new layer after new layer and new layer, then that will make also confuse myself. So what I want to do is that I want to use something called definition query. So right click on the layer like a Pomona parcel. I want you guys to go to the properties. And if you guys click this menu called definition query and add new definition query. Now interface is a lot similar to what you just saw, right? So here I says that a property value is greater than million. And apply and okay. Then, as you can see, GIS only shows me the property whose value is greater than million. This means I didn't delete the rest of them. What GIS does is that temporarily hide the rest of them. So it is really good idea to preserve original data without deleting, but by temporarily hiding that ones that I'm not so interested in at this moment, I can super focus on the records that I am interested in right now, right? So I can do whatever I want to do with this data. As I said, this is I temporarily hide rest of them, so I can always bring it back really quickly whenever I want. So if I go back to the definition query, and if I click this delete button, so I can delete this definition query conditions, I can bring everything back like this, right? So this is one application of attribute query. So you can, temporarily hide things that you're not interested. Okay. And one last thing about query is that if you guys remember what I told you in the morning, when we play with labeling, I told you that I want to come back this in the afternoon and let me explain it. So if you, for example, go to any labeling option and SQL query right there. Now, if I click SQL and if I add new expression, now you understand what I'm talking about. This is the exactly same query functions so that we can, assign the labels that meets with the condition that you set up here, right? You can say, hey, for example, I want to just give it a label for the whatever, right, area is greater than something large number, then we can give it a label for those large polygon only, right? Or things like that. So basically by setting up this SQL query condition here, you can filters out the labels and you can drop the label for the specific entity that fulfill the condition that you set up here. Does it make sense? That's why I told you that I want to come back here. I want to explain in the afternoon, in this morning. Right? So now by understanding the attribute query function, you will understand what your deals with here under the labeling option. Clear, guys? Right? We're good? All right, then let's move on to the one actually last session. Actually, the last session is attribute table association. How many of you guys familiar with this Excel function called VLOOKUP? VLOOKUP? Let me see the hands. How many? One. Okay. Two. No, one. Only one, two, three. Okay, three. Two, three. Okay, 4, 5, 4. Okay, good. So VLOOKUP is a lot similar to what we're trying to do here, that attribute table association. What does that mean? Long story short is that we want to append two tables together. Okay? When we, in many cases, in your GIS project, you gonna end up downloading data from multiple sources. So that when you download the multiple sources, when you download the GIS data from the multiple sources to your database, GIS data is a piece by piece. If you're gonna put them together into the one master data file, what you need to do is that you need to append the two tables together. In order to do this, we need a little bit of base knowledge to have a good understanding of it. So when we, obviously, the concept is very simple. Here, in this table A, and there's another table called table B, and in this table A, there is a land use code field, and table B, also there is a land use code field, and the value in this field, which is 2, I think can be found from this record right here, so that GIS match this row to this row. So when we combine those two tables, append two tables, so we can append this row by row like this, so we can understand, oh, land use code 2 indicates water, land use code 0 indicates unclassified, 1 mean shrub. Right? To everybody understand the concept? Concept is very straightforward. There's a little bit of details that you have to understand, but the concept is very straightforward. So here, the database jargon is that those fields store corresponding values we call keys. So key field in a primary table we call primary key. Key field in the foreign table we call foreign key. Then what's the primary table? What's the foreign key? The table, attached is primary table, and Is it right? So if we attach this table to this table is a primary table, this table is a foreign table. Okay, so I want you guys to remember that terminology called the keys. And if you guys want to conduct this so-called table appending, you have to understand something called cardinality. Cardinality, the concept called cardinality. Cardinality is nothing but database relationship. Okay? No matter how simple or how complex your database is, there's always 4 different relationships, 4 different cardinalities. One-to-one, one-to-many, many-to-one, many-to-many. 4 different cardinality. The number before this word 2 mean number of record in the primary table. The number after this word 2 mean the number of record in the foreign table. So one-to-one relationship means 1 record in the primary table match to the 1 record in foreign table. One-to-many mean 1 record in the primary table matched to multiple records, many records in the foreign table. Okay? So one example, a quick overview is that, see, this table is a property owner table, and this is a property, like a building property table. One-to-one relationship means 1 owner owns 1 building. Then that's a one-to-one relationship. And in the one-to-many relationship, that means 1 owner owns a multiple building, right? Some, I don't know, rich people's may own the multiple buildings, right? So 1 owner owns the multiple buildings. And many-to-one relationship is that actually, you know, co-owners case, right? In my case, my wife and me together owns my home. So multiple owner owns 1 property, 1 building. So many-to-one relationship. You know, many owners together owns many buildings. So let's say my wife and me purchases summer houses with you know, co-ownership. Then we multiple people, me and my wife, on my home and summer houses, so multiple buildings. So that's the sort of example of cardinality, which is very important and soon to be very confusing to you. So I want you guys to kind of pay attention and have a clear understanding, okay? So GIS jargon for this table appending is called table join. We're gonna physically append 2 tables together into the 1 comprehensive master table, okay? So what you may want to remember for table join is that table join is only works with one-to-one and many-to-one relationship. One-to-many, many-to-many relationship does not work with the table join. So let me explain why, and let me explain what you may want to remember, okay? So one-to-one relationship and many-to-one relationships. Once again, this is a one-to-one relationship case. You know, each owner in the owner table, you know, owns 1 property. So we can match using this ID field. So Kate on this property, Jose on this property, so on and so forth. So 3 records here, 3 records here, one-to-one match nicely, perfectly. So if we superimpose table join, what GIS gonna do is that, grab this row, match it to this row, and grab this row and match it to this row, so on and so forth. So the output will be nicely aligned to the record table. One-to-one relationship without any problem with the table join, okay? And many-to-one relationship is a case, actually, as you can see, there's a 4 rows, and there is 3 rows in this foreign table. So in this example, Anne and Angela are co-owners of this property at 999 Lake Street, right? So if we superimpose table join, once again, physically appending those 2 tables together, then what GIS is gonna do is that, yeah, it's gonna match this record and this record, and match this record and this record. And for those records of this 999 Lake Street property, what GIS is gonna do is that GIS is gonna duplicate this record and match it to here and there. So when you get the final product will be this 4 rows table, and this record 999 Lake Street record will be duplicated. So that's not such a big deal with this table join. Okay. But as I mentioned earlier, one-to-many and many-to-many relationship does not work with table join. In other words, table join does not support this relationship. The reason why is that, see, one-to-many relationship, once again, N in this case owns 2 property. So we want to append this foreign table to the primary table. Then I want to think about this. Everything is the final product structure is following the primary table. Then if you want to superimpose this table join, GIS does not know which record that GIS needed to select and append, right? That's a little, confusion and complexity right there. So that's why it does not work with the table join. So one-to-many relationship does not work with the table join. Similarly, when you have the case of the many-to-many relationship, for example, Anne and Angela co-owns those 2 properties, and then if you try to append this table to this table, then GIS does not know, which records of this property should be attached to which owner. So it's a little, complexity and confusion there. That's why GIS is, this relationship does not work with the table join. Then, very common mistake that I found from my students is that they conduct table join without realizing the relationship. So in other words, I found many cases my students just conduct, superimpose the table join even if the relationship is the one-to-many. Then what's going to happen? It will be good to have an error message or warning message. Then my students can see that, oh, I made something, mistake. I did something wrong, right? But unfortunately, when you superimpose the table join with this, unsupported relationship, GIS not gonna generate any error message. What GIS gonna do is that, for example, in this case, GIS is gonna randomly pick one record and generate output. In this case, also, if you superimpose a table join with this many-to-many relationship, what GIS is gonna do is that GIS is gonna randomly pick any record and just append it. So you guys are gonna be able to get some product without any error message and without any warning message. Then you may think, oh, what I did is correct and I got the output and then it's good to go. You may think of that way, but unfortunately, the product is not correct. So garbage in, garbage out. So that's the very common things that happen when you guys push table join without clear understanding of the relationship. So you may want to have very clear understanding of the relationship with two tables that you deal with, and then you may want to conduct table join based on that clear understanding. Okay, once again, if you don't understand clearly what's going on, what you guys are going to be able to generate is not really what you want. Okay, so I want to give you heads up. So I want you guys to have a clear understanding of it. Okay, so let's give it a try to do the table join exercise. For this exercise, I'm gonna take advantage of, not take advantage, I'm gonna use this LA Census block group layers. What I'm trying to do right now is that I want to visualize like a housing unit data from census. A lot similar exercise we did it in this morning. Earlier this morning, if you guys remember, we were able to visualize school children population, right? Similarly, I want to visualize, distribution of housing unit in LA County, okay? But if you take a look at attribute table of this LA census block group layer, so if you take a look at attribute table of this block group layer, unfortunately, there is no housing unit data here. Everybody see that? So, I mean, I like to map housing units in LA County, but I cannot do it, right? So that's very, very typical situation. So as I said, this is the one GIS data file that I download from Census. I mean, if you guys go to the SCAG webpage, and SCAG actually provide some census data nicely mapped, and you can take advantage of it. Let's say, for example, a SCAG RDP, regional database platform, and SCAG actually offer some data already in the GIS format. What I mean by that is that some what's my RDP? So SCAG actually nicely put together census data in the form of GIS data so that you can, quickly download it from like apps maps or content library. And if you guys go to here, you can download the from the so-called atlas or if you go to the content library, you can download the census data already sort of like organized in the GIS data file. You can simply download it. But my point here is that, I mean, SCAG picked like a census data selectively and make it available for you guys. See, that's another the census data, American Community Survey data right there. But some demographic data as well, right? But that doesn't mean that every census data available in the US Census Bureau are available in SCAG webpage, right? So original source of the socioeconomic data is census. Everybody in this room at least know what census is and how extensive socio-demographic economic data available on census webpage, right? So I want to walk you guys through how to utilize, census data for the mapping purposes. So when you guys try to find like some shapefiles or GIS data like this, like a census boundary from census, all you want to do is that search Google census tiger. Okay, tiger here is not an animal tiger, but tiger is unique census. Unique GIS data file developed by Census. So if you Google census tiger, and then you already see now tiger line shapefiles. Now you understand the word shapefile. This is the GIS data file, right? And if you take a look at here, also tiger line geodatabases. By now, you understand, this language, these words, shapefile and geodatabase, and you can quickly realize that, oh, that's the GIS data, right? So if you click it here, and you can go to the census webpage, and you can download the census GIS files here. I mean, actually, one of a file that I downloaded for you to save the time is this layer. So I downloaded it. This data file that I downloaded and I share with you here, that's straight from US Census Bureau webpage. So this is a census block group boundary of the LA County. Okay, straight from this webpage from the census. Okay. But as you can see, when you guys download the GIS file from the census, this GIS file does not contain socio-economic demographic data. The reason why is that there's millions of different data available in census, and census is not able to provide all those data in a nicely organized in GIS format. So what you need to do is that if you want to map census data, you need to download this GIS file, which is only sort of like nutshells, right? Boundary without the database, but only shows the boundary. You want to download this boundary shapefile, and you want to download the data table that you want to map separately, and then you want to append those two tables together. That's how you guys are going to be able to map census data, right? So in order to map census data, you know how to do the table join, appending those two tables. Table one from this layer, and another table that's a table file straight from the census. Okay, so in order to save some time for the training, I download census data from census webpage, and I shared it with you. So if you guys open the folder that you unzipped it earlier in this morning in the File Explorer, as I mentioned very beginning of the today's session, I told you that there is a zip file called Day 2, Session 4, ASC DTY 5Y21 B25001 table zip, right? Everybody has that zip file right there. Why don't we unzip this file and let's go from there. Let's give it a try to unzip it. And let's go from there. Let me, okay. I'll be right back with some water. Everybody unzip it? We're good? How many of you guys lately have downloaded the data file, data table from the census? Do you guys frequently use census data? Right? Really? Yes? Right? Yes? No? Only Riley only? Okay, Alex, thank you. So the reason why I shared this zip file with you guys in this format is that this is the precise format that you can get from the census. I didn't make any modification. That's the data exactly as it is from the US Census Bureau webpage. Okay, I just want to save the time to download the data, but the format. So I just want to make sure that you guys understand, what you have, what you can get from the census. Okay, so the bottom line is that whenever you guys downloaded a data table from the census, you guys are gonna be able to download a zip file, not the individual table file, but this zip file. If you unzip it, you will see 3 files in there, in that zip file. 2 CSV file, 1 text file. Text file is, log file is not that terribly important. And if you read this file name, you guys kind of understand what this table is. ACS, American Community Survey data, 5Y, 5-year estimate, 2021 data, okay? Table ID is B25001. What does that mean by B25001? If you guys Google census, for example, American Community Survey B25001, that's the unique table ID, that table that consists of the housing units. Okay, so as I mentioned earlier, I want to map housing units using census data. That's why I downloaded this B25001 table. And 2 CSV file. One says metadata, the other one says simply data. I mean, metadata means data of data, data about the data. So if you double click and open this metadata file, what this metadata file will tell you is that little description on the field name. right? So we can clearly see or understand, which field is the field that stores data that I'm looking for, I'm interested in. So for example, in this case, A, B25001 underscore 001E, that's the estimate total of housing unit. That's the housing unit total. So that's underscore 001E is the field that stores data that I am interested in. Okay? Then where is the real data, that housing unit data? That's within this data.csv file. So if you, for example, double click, open this CSV file, Excel will open the file. Here, bunch of columns, right? Bunch of columns. And this B25001 0_001E, that's the field of total housing units field, right? So that's what I want, right? I let you understand this much. So that's the actually data that you downloaded from the census. Okay. Now let's bring the census data to the GIS. So I want you guys to go back to your GIS and go to the map and add the data. And in the D2 folder, right? If you guys go to the D2 folder, and if you don't see that unzipped file, you may want to click refresh button. Then you will see the folder that you unzip it. And if you go in that folder, you will see those three files that I was talking about. Now we need to add this data.csv file. Click OK. Then this is the data file, right? The exactly same files that we saw in the Excel, right? And we can bring this CSV file as your standalone table in the GIS. Let me show you guys two tables side by side so we can kind of compare those two tables together. All right, so as you can see, I opened the two tables together. I'm showing you two tables together. So next task is that we want to append these two tables together, okay? Obviously, I want to use my LA Census block group layer as a primary table because after appending the table, I want to map the housing unit data. So this is my primary table. This is my foreign table. Everybody's on the same page as me? We're good? Okay, then let me ask this question. What kind of relationship those two tables has? Is it one-to-one, one-to-many, many-to-one, or many-to-many? What kind of relationship of those two tables do you guys see? See, in order to do the table join, you have to figure out the relationship first, and so that we can make a judgment. Table join is applicable or not, right? So I'm asking, is that relationship that we can apply table join? What kind of relationship is this between two tables? Anybody? One too many? What's the reasoning of this one too many relationship? One makes you think that this is a one to many relationship. Right? Okay, John says one to one, and hey, by the way, this is not a census tract, the census block group. I mean, I hope you guys understand, right? Oh, okay. A lot of debate. Okay. One to one, one to one, one to many, many to many, many to one. Actually, we have 4 different options, and we got all 4 different answers. Wow, which is good. I know. Okay, I got it. Esteban, I got your point. Yes, the one has a 6591, actually not 92. 6591, the other one says 2000. So that's why I want many to one. Right. Marisol, 1 to 1. Yeah. But if you guys take a look at mine, it's 6591, 6591. The reason why you said you see the 2000 there, because the GIS does not show you entire rows. If you click what? See all button or whatever, that there's one button, right? If you click that button, GIS will load up everything, right? Right, expand it all. So, yeah, couple of ways that you can define this relationship. One, the first, conceptually. Conceptual relationship is, I think the most important. Conceptually, my block group layer shows that every single block group in the LA County, and this table 25001 table that I download for the LA County also should contain the information for every single block group in the LA County. So conceptually, everything in LA County versus everything in LA County, right? So it's a one-to-one relationship. And if you take a look at, like a lot of you guys gauging that way, if you guys take a look at number of records, hey, yeah, this table has a 6591 record, and the other one also has a 6591 record. One record in this table match to the one record that the other table nicely matched, right? 1-to-1 relationship, right? So table join can be applicable in this relationship, for this relationship, right? Then let me ask you, some of you guys already mentioned this. Let me ask, what would be the primary key and foreign key? What's the primary key and foreign key? What's the primary key? Okay, why don't we go one by one? What's the primary key? GeoID, yes, right? So this GeoID, that's my primary key. Then what is the foreign key? Foreign key is also GeoID. That's good. But do you guys see the discrepancy? Everybody understand? Yeah. So like a I mean, that's exactly, thank you, Miss Michelle. That's exactly what I wanna. You have to select the end of the number. Yeah. So okay, yeah, I see we're on the same page, right? So thank you, John and Michelle. That's exactly what I want to point it out. Yeah, GeoID here. This is a unique so-called FIPS code, unique ID for each individual census boundary. So in this case, the unique census block group ID. And this GeoID is the same thing. So this is the unique, ID for each individual census block group. But unfortunately, the values stored in those two fields do not exactly match, like exactly the way Michelle pointed out. They don't match. How stupid is this? See, I mean, are we talking about US Census? The most, how can I say, the best reputation they have in terms of data. And by offering this GIS data and data table, US Census may envision that end user like us gonna use GIS and do the table join. But the way they provide the data is not really, get along very well. There's a discrepancy. So we have to do some, extra treatment to, bring those two values in two fields match each other, right? So unfortunately, we are not able to append two tables, excuse me, as they are, okay? Everybody clear? We are on the same page. Then, like John pointed out in the chat box, we may want to select the value and here. So let me make my table a little larger so that you can see better, okay? So if you guys compare the value in those two fields, the value in this GeoID field is that, nothing but the same value as this and, some extra alphanumeric value 150000 US, right? That's only the discrepancy. Otherwise, the value after US is 06, which is the code for the California, 037, which is the code for the state of the county of Los Angeles, and this value that's the unique block group ID. Here, 06, state of California, 037, county of LA, and that value. Okay, so what we need to do is that either we get rid of this 150000 US from this GeoID field, or we can add 1500 US to this GeoID field. Does it make sense? Then the value in two field will be matched nicely, right? So either way is okay, but what I'm gonna do is that I'm gonna add 1500 US in this table. The reason why I wanna do that way is that, as you can see, the add field button in this CSV file table has been grayed out because GIS does not allow us to process CSV table. We can only take a look at it, but not able to process it. If you want to, process or modify this data in the CSV table, you have to convert this CSV table to the DBF file, and there are some steps you have to go through. So I don't want to go that way. So simply what I'm going to do is that I want to add new field in this LA Census block group layer as a placeholder for the new ID field. So why don't I name new ID? And data type should be text because we want to store that alpha numeric value like a 150000 US. So let me define the data type text, and then the length, I think the 50 character will be good enough. So let's save that. And as you can see, I add new ID field, right? Let's populate this new ID field using this calculate field. Once again, Windows. And all I want to do is that I want to, type this 150000 US here, but I don't want to make any typo or anything. So why don't I copy this value, and why don't I paste it? And I don't need anything else. I need only the value up to US, right? And then I want to enclosure that 15000 US value in between double quotation. Double quotation is the symbol for the fixed solid text value. Okay? That's how GIS will recognize, hey, this is the text value. Okay? So I want to copy and paste that value in geo underscore ID field and get rid of anything after US and just capture whatever 150000 US value in between the double quotation. Okay? And then what I'm gonna do is that I'm gonna do the plus GeoID. Do you see what I'm doing? Everybody understand what we're trying to do right now? All we are doing is that we are adding this 15000 US value in front of this the value in the geo ID field here. Does it make sense? Right? Yes? No? So I want to click OK and superimpose that calculation. So if you take a look at it now, new ID field has that very corresponding value, right? Very corresponding value to this geo ID in another field, right? Another table, I'm sorry. So that's sort of like a groundwork that we need to match the value in two different fields. Now you are ready to the table join, right? So if I want to do the table join, I want to start from my primary table, which is the US Census block group layer. And there, I mean, if you guys go to the table, and there is like a table join menu there, but I don't use this table join menu there. The shortcut is that if you guys click those buttons with the 3 lines there, and there is like a join and relate, that's a little faster. So I always use, that's my personal preference. I'm using this shortcut. So join and relate, I click add join. Then here, GIS simply asks you, what is your primary key? Here in this box, a primary table, which is the census block group table. And what's your primary key? New ID field. And the third box, what's your foreign table? B25001 table. And what is your foreign key? GeoID, right? I mean, you can select here, but I mean, constantly in this case, all those default setting is what exactly we are looking for. So you don't have to change anything, but in the case that you need to change anything, you want to change it here, right? So primary key, foreign key, primary table, foreign table, nicely done. And if I click OK, as you can see now, 2 table is combined into the one master table. Nicely done, right? Table join is nicely done. Then I can take advantage of this field that was not used to available in this table, right? So now what I mean by take advantage of is I can map, I can visualize housing units. Right? So the same way, same deal, the exactly same way we did it before, we can take advantage of that data field in another table for this mapping purposes, right? My computer takes a really long time. I don't know what's going on, but just give me a second. The memory, actually, my computer memory is really short now. Okay, so now, as you can see, I am able to visualize the housing unit. Is it? I don't think it's really correct. It didn't update it yet. Okay, now, okay. It's very slow. Right? So as you can see, we can visualize housing units. And particularly in this area, like a downtown LA area, those urban area, you are not able to see the color clearly because of this dominating border color. So what I want to do is that I want to get rid of the border color so you can see better. So I want to change them more, and I want to format over symbols. Go to the properties, get rid of the outline width to the 0. Come on, computer. Speed up. Right? Oh, my computer is really crazy. Okay, so while we're waiting for my computer is working, so everybody got the concept, right? So the bottom line is that you can put those two different tables into the one, then the way that you can utilize any field in any table, you can take advantage of those, the available field, and you can do mapping, you can do calculation, you can do whatever you want to do. Okay, so that's the whole 9 yards, of how to utilize the census data for the mapping purposes, from downloading the data to the table join and mapping and so on and so forth. Okay, so I hope you guys understanding this big picture so that in the future you can utilize any data table in the census for the GIS analysis or mapping purposes. Okay. And another thing is that according to Agile, you can do the table join after table join after table join. In other words, you can have a multiple table joined together. I mean, that's true. I don't doubt about it. But from my experience, when you guys have multiple table joined together, your GIS easily crashed. As you can see, my computer is just struggling with the one table joint. But if you have multiple table join after join after join, it's really easily corrupted and easily malfunctioning, easily crashed. So I don't recommend table join after table join after table join, right? I mean, momentarily you may want to table two, three tables joined together, but I mean that's pretty much it that you want to do. If you guys want to keep adding, like, I don't know, 10 tables together, your computer will be super slow down, and give or takes, it's going to be crash. Your GI is going to crash it. So I don't want to recommend it. So what's the best approach is that you may want to move data or move or transfer the data field, that data that you need from one table to your primary table, and then remove the join, and you don't have to worry about the other tables. For example, I want to think about this. In my situation right now, as you can see, I had a nice mapping. But see, with these tables, only information or only the piece of the data that I need from this B25001 table is this field, right? The data in this field. So what I want to do is that, for example, let me unjoin the first, go to the join and relates again, and I just want to click remove all join, so I can remove the join, going back to the original. And then what I want to do is that I want to add a field. And let me call housing unit. And the long is good enough. So let me create a housing unit. Here. And I'm going to join again. New ID, GUID, all good. And I want to populate this housing unit field using calculate field functions tools. And see, I don't need this. All I needed is like a underscore 001E field, right? And click OK. Then I permanently copy and paste the data in this B25001 underscore 001E field to this housing unit field. Right? Then I don't need this table anymore. I took advantage of everything that I need from this table, so I don't need this table joined anymore. Just get rid of join. Right? See, then I can permanently preserve housing unit data in these block group layers. So if you need any other data set from any other table, you may want to repeat this process. Then you can avoid the situation that you have table join after table join after table join. Okay, so that's the one way that you can address the complicated situation like multiple table joined together and then makes your GIS crash it. Okay, so that's the whole process of the table join examples, also taking advantage of census data, right? So that you can map it and do any analysis with the census data. Okay. One last exercise that I want to do it today is, for example, this situation. So, hold on, let me map it first. So basically, what I'm trying to do is that I want to join this Pomona parser table and census block group table. I want to join those two tables together. Pomona parser and census block group layers together, tables together. I want to join these two tables. But the point is that, I don't want you guys to waste your time to find a primary key and foreign key, that key field. So for example, you say, hey, new ID or GeoID in this GeoID is basically the key or unique ID of this census block group. But if you find the GeoID here, for example, there's no GeoID here. I don't want you to waste your time. I know there's no GeoID here. Original data has GeoID, but I deleted it. Right? So I'm talking about the case that, hey, I want to join those two tables somehow, some way, but what if I don't have keys? The matching primary key and foreign key. So, and what am I supposed to do? As the way the way I explained to you guys before, then you cannot do the table join because table join requires primary key and foreign key, right? Absolutely require primary and foreign key. So that table join does not, if you don't have the keys, you're not going to be able to conduct the table join. Bottom line is that. But in this case, my point is this. yeah, we don't have those keys. I mean, in other words, GeoID in this Pomona parcel table. But if we take a look at these layers with our bare eyes, right, then we see which census block group each properties belongs to. Am I correct? Everybody understand my point? See, if we take a look at this layer and make a visual observation, we know those properties in this one block group, right? So for example, if we define block group boundary as the neighborhood boundary, see, these property in a one block group, in other words, this property is in the one neighborhood, right? Visually, we can observe that, but unfortunately, in the table, there is no keys that we can utilize for the table join. In such a case, we can do something called spatial join. Spatial join is table join based on spatial relationship. Like as I said, hey, this property is within this block group. That spatial relationship. You can join the two tables together. Okay? How in GIS? Actually, let me close the table. And I want you guys to click on the analysis and click tools. I mean, these tools in the toolbox, we're gonna use tomorrow a lot. I mean, if you want to do any geospatial analysis, you may want to find the tool in this toolbox, right? And under this toolbox, I mean, you can type keyword like a spatial join here, and even this very popular, since spatial join is a very popular tools, it show up here already. But if I show you step by step on where you can find spatial join tool, is that click toolboxes, click analysis tools. Under the analysis tools, there is another toolbox called overlay. I want you guys to expand overlay toolbox, and spatial join is right there. So if you guys click spatial join toolbox, that's the tools that we want to use. So here, target feature is that, I mean, you can think of this way. Target feature is your primary table, okay? So either way is okay, but let me choose my Pomona parcel as your target feature, which is the primary table, okay? Primary features. And join feature is your foreign table. So in this case, LA Census block group. Okay? And it will save the output file, like a Pomona parcel file, in the format of a Pomona parcel. So why don't we save this output? Let me call it, let's say, parcel block group spatial join, or whatever names that you want to give, just is the output name, right? And the join operation, it's a relationship. Now you have two options to, you want to choose the one out of those two options, one to one or one to many. What is the, in this case, which relationship do we have to choose? Is it one-to-one or one-to-many? Hey, there's only two options. If you have a 50-50 chance to be right. I mean, anybody has any idea? One-to-many? Okay. What makes you think one-to-many, John? See, I told you when I explained this relationship, I told you that you guys are going to be soon very confused. So here, let me explain this. Once again, the number before 2 is the number of records in the primary key. And number after, yeah, so okay, John, let me get back to you, okay? See, this number, second one after 2, then means the number of record in the foreign table, right? So in this case, Pomona parcel is a primary table, I said. Block group is a foreign table, right? So the way that you describe, John, one census to many parcels, that's the other way around. Right now, that's correct, but right now, the way that we set up is that parcel is the primary and census is the foreign. But according to your definition, census is the primary and parcel is a foreign. You see my point? So in this case, long story short, it's a one-to-one relationship. Why? Because one parcel, individual parcels, only belong to the one block group, not the multiple block group, right? Everybody understand my point? So it's a one-to-one relationship, okay? And match option here, if you take a look at, there's some there's some, let's say, options here. That what does that mean is that how are we going to be able to match it? So for example, we don't have to worry about this case. We can just leave it as a default. But if I explain what does that mean is that, hey, I don't think we have any case like that. But what it says is that, hey, if this is the block group boundary right there, what if there is a property goes, something like this? I don't think we have a case like this, but in the case we have a case like this, do we wanna, if we go with the intersect, GIS may match this inner property with this block group and this block group, or if it says that, for example, have, good, in this case, what I want to select is that have center in, have their center in. That option is that, hey, in this particular case, I want to take a look at where is the centroid of this property. If this centroid is of these properties is in this block group, let's match with this block group, right? So this option is for those a few rare cases on the sort of borderline, right? I'm not going to worry too much about it, but if we go with the have their center in, we can get reasonable outputs, okay? And what I want to do is hit the run button. It'll take a while because my computer is really slow, super slow somehow, some way today. Okay, so in order to save time, right? Oh, it's gone. It's already done. What's going on? Hold on. My JS updating. Okay, it's created. Okay, it's running. So just give it a couple of seconds for my computer. Okay, spatial join is completed. It's done, right? So if we take a look at this output file, output attribute table, right? You will see um, so you will see if I scroll all the way to the right, you will see this census block group table is appended to the my parcel table. So now we know each parcels belong to which block group. GeoID is right there, right? So all those records there share the same GeoID. That means they are in the same block group, right? So once again, if I show you the block group ID, come on. The GeoID here, see that they are all, having all the same GeoID. That means they are in the same block group. Where is it? Right there. Right? So that's how we can combine, those two tables that do not have matching key field. We can combine them together. Make sense? So the question is that for previous table join exercise, is it also possible to put the joined table in a new layer like this one so that, yeah. So if you want to have products that two tables join together, right? Having two tables together, then what you want to do is, let me quickly show you, right? So I got your point. So here I have this census block group layer, and I want to do the table join like the way I did it before. Right? So this will make, two tables together into the one table. If you want to have a new layers, having all those fields together in a one master table, yes, you can do it. What you want to do is simply what you want to do is that you can just export it out. So right click, data, export features. If you export the feature to the new features, then this new feature will have all those data fields. Okay? Any other question, guys? We good? All right, actually, that's all I have for today. So, hold on. Once again, let me quickly, close the session. I mean, thanks for your participation, and particularly, I really appreciate your patience and efforts to stay all day, like 8 hours training session, which is not easy, but you guys, did a good job and stay with me. Thank you for that. And one thing quickly, guys, and if you guys plan to join me tomorrow, I mean, you don't have to, pay attention to here. But if you're not gonna join me tomorrow, could you quickly go and fill out the class evaluation? So I left the link to the class evaluation. It don't takes more than 5 minutes. So could you, if you guys are gonna join me tomorrow, I mean, you will have time to get this survey or evaluation done tomorrow. But if you not plan to join me tomorrow, please fill out this class evaluation. That will help me and SCAG a lot to improve this training session. Okay, so that's all I have, and thank you. And if you have any question, or if you have any things to discuss with me, I'll be hang around here a little further, so let's have a conversation. And otherwise, once again, thank you. I'll hopefully see you tomorrow. Okay. Yeah, let me know if you have any question, anything. Esteban and Pete, do you guys have any question for me? Anything? No? Okay. I'll see you guys tomorrow.